So the next person identifies themselves as Balu. Why? Because they look like one. And of course, because they like you are already a wild guess. No?
Kapan can take it.
So I don't have anything to present, but I would like to use the board in case we could all shift that.
Sure.
Yeah.
And also probably because I'm in Delta, maybe, just maybe, so that I can drive a plane someday.
You can wish for it.
Fly high.
Yes.
So, good evening. My topic is somewhat interesting. It's different in a way. My topic is 80-20 principle, or Zipf's law, as we can call it. That's the another name for it. So, did you know that 6% of all the words that we daily encounter, say in speech, while reading it, while writing, is the word the? The word the is so common that every 16 words that we usually use in every 16 words that we usually use, you'll find at least one the coming around. And this might be just a fun fact or some trivia we can call it, but if you look at it even more closely, you'll find something even more interesting. So let's say you were to arrange all the words in a book, or even in an article, or even in a whole language, into which are ranked based on their occurrences. If you were to plot them in a graph or something of that sort, you will find that it looks something like this. And it's such that the second most used word will be half of the most used word. The third most used word will be 1/3 of the most used word. The fourth, 1/4, the fifth, 1/5, and so on. If I were to plot across all the graphs, I'll find that it makes this kind of curve. And in mathematics, we call this something like the power law. And power law is such that the frequency of the word is equivalent to 1 by its rank. And it is very difficult to digest something of this sort, that something as creative as a language can be manipulated in something as simple as a mathematics equation. It's like it just blows our minds. And this is not something which is specific to the English language. You will find that in each and every language that we know. Even languages which we are unable to translate up till now, ancient languages, will also have this thing. And this particular graph or plot is the Zipf's law. And the funny part is, the Zipf's law just doesn't apply to word occurrences. You'll find it everywhere. Say protein synthesis, say things like population of different cities, the traffic a website gets, even the amount of things that we forget follow Zipf's law. And this Zipf's law is very simple in saying. And if you look even more closely, you'll find that you can somehow draw an imaginary line which separates the graph into two separate parts. This part is around 20%, and this part, the whole area, around 80%. And you can say that 20% of whatever you do will get you 80% of the outcome. This law is also, this particular thing is also called as the 80-20 principle. And we really don't know why this occurs. We don't have some firm conclusion on why something of this sort can occur. But we have some different hypotheses on this, and I'm really sorry because the word ask is ranked less than the word answer. But at the same time, knowing is is ranked less than mystery. So I'll try to hypothesize on why something like this can occur. So Zipf's law is popularized by Harvard professor known as George Zipf, and he believed that Zipf's law in English language occurs because of the tendency of living things and non-living things to follow the path of least resistance. He meant to say that as our language evolved, speakers tried to use as less words as possible to put out whatever they knew. And the listeners, on the other hand, preferred more amount of vocabulary so that they could understand the specificity of what the speaker was trying to say. So Zipf thought that eventually, because of this, it would result into a 80-20 kind of thing. That 80% of the words were rarely used, but very few words were used often. The 80-20 principle is not just found in languages, as I just said, it is found everywhere. So let's take some real world examples. So right now, if you see the wealth distribution in the world, you will find that 20% of the richest has around 82% of the wealth. And you will also find that 20% of the patients in USA consume 80% of the healthcare resources. Also in 2002 or sometime around that, Microsoft said that 20% of the bugs were causing 80% of the crashes in Microsoft Office and Microsoft Windows, which is very interesting to understand, to think about. But at the same time, another researcher has a different approach to this. He says that even if you type random words in a keyboard, you will find that it also follows Zipf's law. So it's not something to do with English language or humans. It is something which is mathematical. And can you imagine something as creative as our English language being so simply told by using random keys? Well, that doesn't make sense. But the way he hypothesized this is also very interesting. He says that there can only be 26 one-letter words. But as the length of the words increases, say 2-letter words, so there can only be 26 square 2-letter words, 26 cube 3-letter words, and so on. So that's why he says that even that follows the Zipf's law. But so we really don't know what is it that results in this distribution. But I'm very happy about this distribution because I can understand that by just doing 20% of what's wrong, I can solve 80% of the problem. Thank you.